Uh, Thanks everyone for joining in. In today's session, Lakshmi is going to talk about how the AI is going to. We have to embrace the AI. Or the roles are changing, and with his deep industry knowledge, he's going to help us understand how we want to um, the new AI era and accept and thrive. He has spent more than 20 years in building very serious systems across search, Java, large scale platforms, and now on AI. He was part of an engineering team, core part of OpenJDK at IBM, led high performing systems in eBay and Amazon, uh, shaped key platforms like in Uber, and then driver onboarding process, and now as a director of engineering at Capital One, where he builds a deep system engineering with modern AIs, building at scale. And also right now he's also dedicated to educate about LMs to all through various forums. With that, Lakshmi, the stage is yours.
Thank you, Nanda. Thank you for the nice introduction. Thanks a lot. I'm a learner still. I just call myself a pragmatic engineer. I'm nothing more than that. This space is new to all of us, so we'll try to collectively learn things as we go to here. Let me quickly share my screen. Just give me one second. All right, you guys can see my screen?
Yes.
Awesome. All right. So let's get started. So about me, Nanda told everything about it. I just want to call myself an engineer. I just love building systems, writing code, learning new things, and large language models. And as an outcome, generative AI have been something which have been very, very close to my heart recently. So that's a space that I kind of work a lot of my time now. I did a lot of random stuff in my past life, so to speak. Started on working on building the Java virtual machine, then started doing things at Amazon, large scale distributed machine learning systems. And at Uber, I worked on maps and then driver onboarding. And here at Capital One, currently, I work as the director of engineering, focusing on systems that help our customer support agents have a better experience. Um, I again consciously call myself a pragmatic engineer because I am not somebody who just falls for fancy keywords. I try to evaluate and choose the right systems as we go forward. Okay, what are we going to do? This is going to be more a discussion. The slides are just for us to expand our thought, challenge our thinking, provoke some discussions. So please feel free ask questions anytime during the session. More than happy, because that's how we are going to learn. Um, Uh, I started giving this talk at first primarily because I saw a lot of confusion in people's mind in terms of what generative AI is, what are large language models, is it going to take away my job? What do I do? This system looks so alien to me. How do I relate to it? So a lot of this deck that I gave earlier at UiPath now and a series of blogs that I've been writing are primarily to dispel the myths and hopefully help engineers get some sense of how do they find their place in this world of large language models and generative AI. Um, Generative AI is not magic. It's an evolution path for people who have worked on what we call as artificial intelligence and machine learning. At the core of every generative AI is basically a massive neural net. With the with the advent of a new system which is called transformer architecture, we have now been able to kind of take data, understand the structure of the data, and be able to process the data at scale that was never imagined before. Now that led to the evolution of the first sort of large language model, which is called BERT. From there, things have slowly started evolving, and when people started realizing that the transformer architecture can be used to encode not just text, as what we use with ChatGPT mostly, but it can be used to encode programming languages, which is what you see with newer tools like Cursor, Replit, Claude. Any of these systems which are generating code are, at the end of the day, they are trained with how do I transform, how do I understand the code, what are the pieces of it, etc. Down to generating images, generating music, generating video. All of the foundation starts with transformer architecture, which has been an evolution from the earlier generation of neural nets per se. It's true, careers are shifting. Subsequently, we will talk about how do I make sense of this beast, what we are calling as generative AI. What does it mean? How do I touch? How do I feel with it? How do I interact with it, etc. But it doesn't actually necessarily take away the core of what we are at the heart of it. It's not a shortcut. A lot of people tend to think that, okay, it's two things that I learn. I attend this course, I take the certification, now I am a Gen AI specialist. It's absolutely is not. This discussion and maybe subsequent interactions, if we have, will kind of help us provide a map of how do we go through this journey, what we call as generative AI, as it's shaping up. I really like this analogy. For some reason, I just randomly came up with this thought of what is an LLM? Think of a child. Like if you have children, then your child is no different than an LLM. It's just that think of the child with a superpower. Children require precise instructions. Large language models also require precise instructions for them to operate. Clear boundaries. Come home by 6 p.m. is a very clear boundary that you might set with your children. LLMs also require those boundaries to operate effectively. Guardrails, don't go beyond this boundary, don't go stay. It's also very important. You might see some of it coming as part of the prompts that you give to the large language model. And continuous feedback. You keep teaching children when they make a mistake, how to correct, etc. And that's how large language models are. So at the core of it, rather than think of it like a conversational system which can take some of your input and translate that into either working code, an image, music, video, anything that can come. But the way you interact with that system is through natural language. It's primarily brought a paradigm shift of generative AIs. So bottom line is, yeah, if you know how to parent this child, you can actually use the full benefits of it. Right. Now, with that, we'll slightly understand our what we call as traditional or deterministic computation systems and generative AI engineering or statistical modeling systems. Are they very different? What's primarily the difference between these two? In traditional engineering, there is generally a deterministic outcome, which means if you say what is 1 plus 1, the system will always tell you 2. But in a large language model or a generative AI system, there's a probabilistic output, which is why sometimes you might have seen for the very same question, the models respond differently. That's something that you have to know, accept that this is the difference between traditional engineering and generative. In traditional engineering, you need to tell it the exact logic and its precision. In generative AI, it's context-based reasoning. A lot of it is based on what previous interactions that you have had, how you structure a specific question, what is that model specialized in. That's what primarily drives the outcome that's going to come. Traditional engineering, you talk to the system via code. In a generative AI or large language model system, it's a prompt, which is you talk to it with a pipeline essentially to be able to kind of fetch information that's needed, etc. Predictable behavior, as I said, it's a probabilistic behavior. So you have to know where can I not use generative AI systems. Fixed rules and workflows, it's adaptive systems thinking. The system continuously keeps changing as it gets more data, as it finds newer sources of information, it can continuously change. What it then means is the stronger evaluation. You need to be able to evaluate the system with a lot more focus than what you had to do with your traditional system. So I hope the difference is at least broadly clear in terms of what these systems generally look like and work. And with that, we'll talk a little bit more about how with this massive superpower child that's out there, which is democratizing code generation, content generation, image generation, all of it, do current set of engineering roles, do they find an equivalent role, or what is that the role might change with in this new paradigm? I took a few, and in fact, if you have chance, go read up some of the LinkedIn articles where I would have gone more deeper into specific examples of how these roles may change. Um, a QA engineer, so currently a test engineer or an SDET or a test architect, they focus primarily on writing test cases, testing the boundaries of the system, repeatedly proving the functional correctness of the code that they are validating. Now, replace the code with a large language model. Now, the large language model comes with all the nuances that we talked about in the previous slide, which is it's probabilistic, it is continuously evolving, it may not be always accurate. So, how do you test this system now? You no longer can expect a deterministic outcome from it. So, a QA engineer sort of becomes a guardrail architect, which is they have to now test, hey, what are all the boundaries that I need to define, and how do I test whether the system operates within those boundaries? To some extent, this role also changes into what we call as being able to test the hallucination of the system. Um, you would have seen, you ask any random question to ChatGPT, it'll think about some random answer and give you. And if you say no, that answer is wrong, it'll say yes, yes, you're right, that answer is wrong, and then it'll come up with its own set of answer. So this is what we call as hallucination. So QA engineers will have to now start thinking about how do I test whether the system is actually hallucinating or it's actually giving reliable and to a larger extent correct set of answers. If you're a backend developer, your role is very, very pertinent. Um, there's a fantastic person called Sulaiman, if you follow him on LinkedIn, who primarily put a very nice iceberg picture talking about the fact that generative AI is actually only 5% of AI and 95% of engineering. A lot of critical systems are still very deterministic in nature and requires real software engineering to be able to plug these systems together, all the way from your pipelines to your RAG infrastructure to your cloud hosting to model execution to observability to metric generation. These are all systems that will continue to remain exactly the same as what they are today. So if you are a backend developer, your role, you'll have to start looking at how do I orchestrate these systems. Okay, I now have, I don't know whether we'll have time. If we have, we'll talk about agentic AIs also. But rather than writing in individual pieces of it, think of these pieces as like agents and say, how do I now orchestrate these systems together? How do I pass data between them? How do I collect data? How do I process them, etc. Um, software developers,
So,
exactly
Lakshmi,
like,
I have a question.
sure.
Yeah. So on this QA engineer, like, I mean, in the past, I worked as a QA engineer. That's why the curiosity. Um, if I'm going to use LLMs to augment or reduce my work in the QA development cycle, first thing that comes into the mind is like yeah, it can help me generate test cases, right?
Yes,
And okay,
yes,
and then I can stretch it and then go to the next step of making it also to execute. Again, there
exactly.
is a definitely human in loop where I need to come and check whether generated test cases are really matters a lot for this particular software or not. Then comes when
Um,
it yeah,
y-
then comes the execution part. You know, let's say
yes.
that we make this tool work with external tools to execute, validate, and then come up, right? Um, so all the things that you said, act as a guardrail, define the boundaries, everything fine. Um, this is definitely going to scale in execution. Previously, if it takes 3 months, 3 months for us one release to go outside with getting the LLM, everything, it can reduce to 1 month or even less.
Yeah, yeah, absolutely. Yes. Yes.
So, a question here is. LLM is generated based on the probability, right? And
Yes.
it has read lot of it has seen lots of use cases, generic test cases, and then it is going to come up and may not suit my system.
Yeah.
How I mean, how a QA engineer can, keep refining this and then make it more tailored? Is it going to be like he has to completely build its own the application layer? What when I say application layer, like the agentic layer, he has to build using any LLM model, or how is it?
Okay. That's a very, very good question and sort of a very important and a very broad one also. So um, let's break it down into two parts.
Mm.
Now, the reality is majority of us are going to be working still on very deterministic systems. So if
Right.
you are a test engineer in an organization which is building a CRM module or an ERP module or an accounting module, now those systems are very deterministic in nature. You cannot have probabilistic outcomes saying that with an accounting module that can either report your balance as 1,000 rupees or 500 rupees. That's not never going to work. So those
Mm.
systems are always going to be based on deterministic computation systems, which is the traditional software backed by relational databases and maybe some programming language, etc. And honestly, they are the best for that because they're very fast. They always are reliable. They are idempotent, which is they will keep giving the same results anytime you call. There, the focus of a test engineer is more around, hey, how do I use these tools to automate my work, identify weakness or weak points in the code and the system that for which I need to build guardrails by automating the test case generation and test case execution. Where LLMs really, really scale, if you are familiar with Copilot, Cursor, or any of the other systems, is given a code, they can come up with a lot of combinations of outliers, test case generation, data points that can actually break the system, etc. And that's where your focus will be. So for deterministic software systems, a QA engineer and a lot of engineering roles will move more towards efficiency, speed, automation, and that's where it will be. Now, if you are a QA engineer today who wants to kind of work with a generative AI system, a large language model, the the thumb rule generally that I keep telling people is to magnify your strengths and manage your weaknesses, which means what are the strengths that you have learned as a QA engineer? As a QA engineer, you have built the capability to understand the system a little bit broader, knowing what are all the functional aspect of it, what are all the weak points in the system, what can break, and be able to pressure test the system with different kind of input and outputs to see whether it's returning the right value. Flip it around for a if you're testing an LLM. Now, a lot of those things are there, which is can you pressure test the system? Can you give it different kind of inputs? Can you actually test whether the system is returning a probabilistically correct answer? Accurate is very subjective to interpretation. Now, that is the basic set of things. Now, if you remember, unlike the earlier systems, LLMs can sort of think, which is that's where they start hallucinating, coming up with a random set of things. Now, the guardrail behavior becomes a far more critical component for you to think of because that kind of puts the barriers within which your model can operate, which you can then write test cases to check and see whether it is working correctly. So the strengths exactly the same. How you translate those strengths, you start realizing that I have to test the boundaries of the system, making sure that it doesn't randomly go on some give answers which are totally invalid, while testing it with different kind of inputs and outputs to check whether the answers are returning correctly. Did I answer the question,
Yeah, yeah,
Nanda?
yeah, yeah, yeah. I got the points. Thank you.
Okay. Towards the end, if I have time, we'll kind of point you to some articles which talk more detail about it.
Sure.
Software developer, as I said, I think you already are using it for primarily building code. So accelerate your development, test cases generation, documentation. So I think that's bread and butter. That's going. Your role is still going to remain the same. There's not much of a difference going to be. System architects, yes, your role is absolutely relevant. It's just that now you are operating with a large infrastructure, AI infrastructure, GPUs, concurrencies, probabilistic systems, and then essentially becoming figuring out how do I architect or orchestrate between multiple systems? How do I build consensus across multiple AI architectures if it has to come to that? How do I build a RAG pipeline? How do I build an agentic AI pipeline, a workflow through of it? So the role becomes very, 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 very critical and very, very important. Data analyst, um, interesting, right? Data analysts used to be spending most of their time running complex queries, taking the data, exporting to Tableau or Sheets, or running massive R, Python, Scala code to visualize the data, to get data points, etc. Now, the mechanics of how you extract information from the data is obviously changing. Um, Systems can now do all of those at scale. So you just need to know what is the right kind of questions that I need to ask. What is the right prompt? What is the right guardrail? Do I understand the data quality? LLMs cannot do a great job in fixing the data quality by themselves. So which is where your job will more be about how do I help the system build the right data quality? How do I prompt the system to get the right information from it, etc. The last role, which I did not put over here, I don't know which there in the next slide. Um, Sorry, DevOps. If you're a DevOps, it's a field day. DevOps, Cloud Ops, your role is far, far more significant with most of these computations kind of moving to the cloud. You are in the prime of your life, so make sure that you upscale yourself to understanding deploying GPUs, scale up, scale downs, then your job will be the most critical one to ensure an organization success, which wants to kind of move into the window. One of the questions that I keep getting asked is about people, okay, hey, so I just passed out of college, or I just have years experience. I see these things, Gen AI enthusiast, like what do I do? Where do I start, etc. The short answer is understand the basics first. A lot of us kind of jump into ChatGPT and then Cursor or Replit or any of those lovable and then start doing things. If you are an engineer, it is very important that you understand the transformer architecture. There are fantastic training materials, YouTube videos to actually understand what positional encoding is, what does embedding actually do, what does inference actually do, how does a LLM actually interpret the answer that you're asking for? How does it get it from, and then what are the difference between these various systems, etc. So most of these LLMs also provide some sort of an API interface for you. Then learn the fundamentals, understand how do I write these APIs, what is the data, how do I write these workflows. Be real, write code. Um, that's the best way for you to learn. Write code, put it into your GitHub repository, share it with your friends, ask them to review it, you review others' code. That's how you actually understand how these systems work. Don't chase hype. This space is just evolving so rapidly that it's very easy to get lost. Every day somebody comes up with some new embedding model, some new way of compressing tokens, some new GPT 5.1 has come, Gemini 3 has revolutionized this, whatever, Nano Banana has come. Like, don't chase after all of those things. If you get your fundamentals right, if you understand how these systems work, then all of these noise will still be noise for you. You will know the core of what you're trying to build, how are you going to build it, etc. Focus on breadth before depth, um, which is understand the various components that go into making an LLM and then go deeper into one area and understanding. The reason why I said it this way is because when you go only deeper and don't understand the breadth, you become handicapped. You do not know necessarily how do I build these systems. How do I use LangChain or Crew AI? So understand some aspect of breadth and then go deeper in this. Um, if you are in a large organization, prove your value to your company. Start writing automation systems, build internal tools using generative AI, large language models. That will actually help two things. One is you will learn. Number two is you will tell your employer, you are signaling your employer that you are ahead of a lot of people and are not just theoretically knowing things, you can actually show value to your company by building these tools. So those two will become very successful for you to grow in your career because your organization know out of a lot of people, you are somebody who can actually, you who is actually bringing in value to them as of today. I don't know what. Okay. Sorry if the slides are a little jumpy, but now that we kind of learned about how career transitions look like, what do you do if you're an early tenure employee, etc. This is just reiterating what was said earlier in terms of the difference between traditional and generative AI engineering per se. Understand that you're moving away from tools. It's no longer about Redis or Spring Boot or frameworks and tools. It's about systems thinking. Remember that generative AI, large language models, in a lot of extent, encompass many things inside them. So it's not about mastering every single tool that's out there, but understanding the flow of data, understanding the flow of information, the flow of interactions, and how do you build these systems in a robust way? By robust, I mean how do you guarantee uptime of these systems, resiliency of these systems, and how do you control the behavior of the system into it? Remember the child with superpower. You have to somehow rein in this child and keep this child in check. So how do you kind of build those control systems in place to ensure that the behavior is guaranteed or at least consistent into it? Uh, Second is pretty obvious, right? Like code is no longer how you translate a business problem into a solution. Now it changes into prompts. So how do you interact with the system? How do you define policies for it? How do you build the pipelines that can transform the data or move the data between these two systems? So you now design the behavior and not just the features. Because the system will internally figure out the features per se. The system will internally figure out, I need to have 4 classes. I need to have this override. I need to build this inheritance here. I need to put this function block in this code. That the system will internally figure out. Your job is to drive the behavior of the system. Now, this means that you need to know, how do I talk to this? Just the way when you go to a new place, you learn the language of the place. Uh, it is important that you understand the language of the model that you are talking to. The good thing is largely prompt engineering is fairly standardized. There are predefined set of prompts, templates, structure of the prompts that can guarantee some element of this for you. So knowing how to write effective prompts, establishing safety rules either within prompts or as validation systems around it, building evaluation loops, which is testing the behavior that is coming back from the LLM, and creating retrieval pipelines, which is pipelines that actually get the data from other systems and feed it into this, or take the data from this system and feed it into some other systems, becomes the primary way through which you actually interact with the system and derive value from it. Last is, you can no longer guarantee a specific output. Okay? LLMs are great at it. You can ask any question, it will answer anything. So the real challenge is to make the output meaningful, reliable, consistent, and trustworthy at scale. So you have to at some point realize that you cannot control the output, but you have to somehow figure out a balance between what comes out of this. So there's no absolute output that you can expect to come, but a borderline or a broader range of output that can come from it. How do you kind of effectively guardrail it so that for your systems that is consuming from a large language model, the outputs are still reliable, consistent, and trustworthy. What is there here? Okay. All right. How do you do this now? Now that we have learned all this GAN and things about generative AI, magnify your strengths, manage your weaknesses. You are already good at something. Make sure that in that specific domain, if you're a QA engineer or a DevOps engineer, um, make sure that those strengths are magnified in the generative AI world. Understand those spaces well. So if you're good at domain knowledge, make sure that you're able to showcase your excellence in the domain knowledge with LLM tools, generative AI tools, etc. We talked a little bit about how your skills can map into the Gen AI landscape. Uh, know that and learn specific aspects of GPU deployments. If you are a data engineer, understand how RAGs work, how vector DBs are actually structured. So these will actually help you understand a little bit more deeper about how your current knowledge relates to how it will be in a Gen AI world. Nothing beats nothing beats coding, nothing beats building things. So have two, three, or if possible, more set of solid projects. By solid projects, we are talking about if you're very serious, then starting from a single LLM to building a RAG pipeline, building orchestration with multiple agents, um, building observability, monitoring systems around it, interacting with real world wherever it's required, pushing some of this RAG data into a vector DB, and then being able to retrieve this information, etc. Learn tools that matter. As I said, there's a lot of hype. Every day, 1,000 things keep coming up here. So focus on APIs, tell you the guaranteed way in which you'll talk to a large language model. I talked about vector DBs. Vector DBs are how these models internally store the information that is given to them that they have learned, and also they translate your query or question into an embedding, which is called a vector embedding to this. Understand workflows, QAI, LangChain, there are multiple things. How do these systems talk to each other, etc. Uh, the beauty of Gen AI systems, if you're especially a coder, is that it's very easy to get started. You just give it a beautiful prompt and it does something magic. So there's a huge benefit that you will see immediately that, wow, it suddenly wrote 25 Python scripts. It nicely segregated these modules. It did everything. Then debugging starts. That's when the real thing starts failing because you had zero idea about how things were built, what went where, etc. Then you start becoming more and more reliant on Cursor, Copilot, or something because without which you kind of have no idea about how it was built from. So start working at least with good quality control in place, which means start with writing simple code, simple test cases to start off with, and then iteratively, as you prompt it to write something, make sure that you add test cases, you at least ask it to write test cases so that there is a lock-in step in terms of code validation as the system progresses. So that way, two or three things can happen. One is you can actually test how the system is performing at every step and hence roll back to a previous version if you think something has really gone bad. And you start actually realizing that the test cases are how you are actually interacting with the system yourself. The large language model generated a beautiful code. Now you don't know anything about it. For all practical purposes, that itself is a model. And test cases are the only lenses through which you understand how the system works. So it's super important that you build slowly, build test cases, think about quality from day one, think about to a large extent observability from the time you start prompting the system. Because sometimes it becomes very difficult to retrofit some of these things later. Um, what else is there? Okay. Some options in terms of how you can think of nice building a portfolio if you want to build some interesting projects. Some of the things that you can think of is yeah, like how do you build a system that can actually test and improve or measure the output from an AI system. You can build a RAG. If you have questions, we'll talk about RAG specifically. Pick one use case. Try to build a retrieval augmented generative model on top of it. It's very easy. Now it becomes very specific. You can build your own chatbot for example, with your own custom data. And then the chatbot is now trained to read through all the data that you gave it to us. Let's say you're running a website which is very specific about organic foods, let's say. Now you can actually get all of this data, generate an embedding with only your data, and then you can feed it to a large language model. And it can be a nice chatbot that you can demo on to say it can answer questions about your organic products very specifically based on what input you gave. So that's a good way to demo and understand how RAGs work. Prompt libraries. So this is also a great things, right? You can actually publish nice prompts that people can reuse. So it's a good way for you to showcase your knowledge. This is like a code or a HLD that you're pushing out there for people to see, hey, how nicely I'm writing a system or designing a system. So write, create prompts, publish out there. So there's a good way for people to know how do we structure a good prompt for, let's say, building an image processing system. So what guardrails you put in, what tests that you're putting in, how do you control the amount of memory, how the cost, all of those things, etc. Hallucination, great. So uh, hallucinations are the Achilles heel. See, systems behave very differently. You don't know what's thinking through it. How do you actually build a hallucination tester? How do you build code, or how do you write something which actually tests whether the system is hallucinating or not? And can you, for example, come up with a score to measure the hallucination of the system and prove that with subsequent prompting to fine tune the system, fine tune the system, fine tune the system, the hallucination number goes down. So this is one good way for you to show that you understand what hallucination is, you understand how good prompting can put the guardrails to ensure that the system does not hallucinate. Um, Last but not the least, these are tool calling agents. Nanda runs a lot of these courses. So, how do you interact with real world tools? For example, can you call the weather API to get the weather forecast, or contact Yahoo Finance and actually build an AI agent that automatically analyzes stock portfolios, looks at current EPS, future EPS projections, compares it against peers in the same industry, and then comes up with a recommendation for whether a stock is worth investing now or should you wait for some time in the future. This can be plugged into news databases, for example, get information about the stock, and then maybe actually, if you're writing it in India, then you can actually connect it with the NSE or SEBI to actually find out are there any board resolutions, look at the last quarterly results, analyze all of it, and then come up with a recommendation. So these sort of projects actually showcase your ability to build a model and also be the ability to connect with tools that exist out there to retrieve information and then process them and then come up with a recommendation for it. With that in mind, this might be a repetition. As I said, APIs, understand the APIs that some of the most common LLMs provide, because I'm assuming some of you will be using it. If you're interested, I will show you what I do on my system. Vectors, Chroma, FAS, these are great systems or great vector DBs that you can build locally for your RAG models that'll store your embeddings, and then it'll help fine tune the LLM to focus only on the data that you have. Workflow frameworks, LangChain, Crew AI. So these are systems that allow you to chain different agents or chain different workflows together to build one output. Like we talked about the stock analyzer, right? Like one part of it could be your LLM, and then the next part of the chain could be talking to Yahoo Finance. The next chain there could be to talk to NSE website and pull the quarterly results, etc. So these are all good ways for you to understand how do you connect different systems. Evaluations, so performance, hallucination, these become very critical. So there are tools like Deep Eval and Ragas, which allow you to kind of measure hallucination and performance of it. And then with good prompting, good fine tuning, then you can actually come up with scores to see that these numbers are actually reducing and your model is becoming better and better, etc. Um, Understand good prompt patterns, whether nice architectural patterns, nice architectural structure to your prompts. Uh, that'll help you draw value from your L. Now, for a lot of us, we actually use publicly hosted LLMs, which cost us money. So the ability to know how a good prompt can optimize cost for the value of code or output that it's generating is a good way for you to understand prompting. It's like understanding the language of the person. Should I say 15 words to that person to get the value, or can I say only 4 words? So there are nice tools that are available to optimize the prompts. There are different token libraries that are available to take your prompt, convert it into much smaller tokens so that your cost is still under control if you're talking to these models, etc. So these are stuff that we can learn to understand things. Um, okay, all right. This is the last slide. Okay. Don't try to be someone else. There's just too many people out there talking about too many things. Understand your strength and try to find your place in the new world, so to speak. So clarity over complexity is super important. We need to be clear here for us to be clear in the real world. So simple, well executed solutions always beat over engineered approaches. So this has been there for generations, this philosophy. So it's called Occam's razor. The simplest solution to a problem is most likely the correct solution to a problem. So focus on simplicity over everything else. Curiosity over experience. Yes, this field is young. Eagerness to learn is will help you go a long way. We talked about this, right? Think of a big black box which has this magic power. So you move away from syntax to systems thinking. How do you talk to it, etc. Strengths over certifications. Yes, a lot of us think certifications are a great way to demonstrate our credibility in this space. Maybe for some spaces, if you want to just get a job, but I have zero certifications in this space. So remember that repeated practice, making code, demonstrating that you know about things is a better way than merely certifications there. Okay, all right. I think I'm done here.
Well, Lakshmi, that's
Hmm.
I mean, you kind of covered a lot of aspects and then how it is going to evolve, how things are changing drastically, right? And how do we embrace and adapt and progress? Great insight. Any questions from you?
So we fortunately report to him in our office. So
Oh my God. Okay. Half of my team is here. Okay. Sorry, guys.
no problem. So
Okay.
we get like a lot of insights every day. So we are very fortunate in that aspect. Yeah. We don't want to again take that questions here with Lakshmi. So we will have it separately.
Yeah. Avinash, you have any
Yeah,
question?
I just wanted to say one thing. Like the perspective in which this was presented, a lot of ideas in the slides were actually like there are things we hear about, but hearing it in this perspective, right from the way you defined what is the potential of an LLM, and then what are the practical approaches we can take to increase our skill set, adding on to what we already do.
Yeah,
So that I think
yeah.
that was really inspiring. I think if you can share a copy of the slide, it will be really great. Uh, love the thought process here.
Absolutely, yes. I think Nanda, you
You
already
can,
have it. Yeah,
uh,
sorry.
okay, I can,
Now I don't know which is the right place to publish it to your people. I'll send a copy of this
if,
over to you.
no, if there's a I mean, shareable URL is there, you can put it on the chat window now, if that is possible.
Okay. It is possible, but I just realized that my mouse battery died. So I'm like,
Okay.
my keyboard is working, but my mouse is not working.
All right, I'll see if I
Sorry about
can
it.
share.
Yeah,
No,
you,
let,
sorry.
let me see if I can share it. If I have it, I can share it.
Sure. If not, I will also put it up on my LinkedIn. My name is Lakshmi Narasimhan. Hopefully, you can find me on LinkedIn, so it'll be out there for you to look at.
Okay.
Again, I'm not an expert. I'm just learning myself. Um, so yeah.
So, Lakshmi, what's your thought on private LLMs?
Okay, that's the part that I wanted to actually show you. Why don't you just give me 10 seconds? I have a
Sure.
USB mouse. I'll just plug it in. Just give me 10 seconds.
Private LLMs, you mean like local on your own?
Yeah, it's a
Small.
private to my knowledge, private LLM, say for example, many people, many organization takes the OpenAI LLMs and put it onto their own cloud and
Okay,
build intermediate application and then work with your own LLM so that your what are the employees prompt response, everything stays within the organization.
got it. Got it.
All right. Okay. Thanks to archaic systems, I'm back. Great. You talked about private LLMs. So at the root of it, okay, I hope many of us understand what LLMs are. Like, does anyone have a question on what LLMs are? Okay.
So
All right.
just shared the slide deck on the Zoom
Yeah,
window. Okay.
Okay. All
thanks
right.
a lot.
Okay. So we all know what LLMs are, right? I mean,
On a
not the
high level,
definition per se, not just the definition of LLM meaning a large language model. So okay, here is what it is. Think of it like ChatGPT. Okay, let's say I give you a sentence like, "My name is Lakshmi Narasimhan." So this sentence has my name is, let's say Lakshmi Narasimhan is a single word, so there are 4 words in it. So my comes first, name is second, is third, Lakshmi Narasimhan is fourth. So in before we had what we today call as the large language models or transformers per se, the systems had only a positional way of looking through this my name, and then they would actually forget what came before this, etc., and all of those things. Transformers essentially said, okay, hey, every word has a position associated with it, and think of it like they kind of put it in a matrix and say my is 0, my is 1, name is 2, is 3, Lakshmi Narasimhan is 4, etc. Now they look at this over millions and millions and millions of data sets. Like ChatGPT, for example, they say it's trained over 40 terabytes of data, which is essentially the entire publicly available internet data. So it basically builds this massive probability score of saying that what is likely to come after my. Okay, it looks at the space of what all it has learned over all of these things and then tries to come up with an answer for it. So ChatGPT, or I should call GPT. GPT is essentially is a technology behind it, which is the general purpose transformer. Is a massively it does 2 things. One is it's trained over massive corpus of data, and it runs on millions or I don't know gazillions of GPUs for you to be able to return data in a very short amount of time. So when it comes to large language models, there are basically 2 steps. One is the embedding, the other step is the inference part of it. LLMs, which is GPT, Gemini, all the Perplexity or any of that sort, for example, the inference is already built into them. Sorry, the embedding is already built into them because they have been trained with corpus and corpus of data. So they have this massive index of all the data with positional encodings, etc. So when you ask it a question, it basically looks into its huge memory and then inferences and then gives it to you. Now, this is also a waste because if you are specific that, hey, my data needs to be only around a very specific subdomain, uh, image generation. Now, an image generation does not need text data at all for it. Or let's say you're trying to build you're trying to build a transformer model for a chemical processing industry. It doesn't need to know about anything about arts or paintings or any of those things. Why GPT is magical is because it answers practically everything that you ask it for with some level of clarity, some level of accuracy, because it has been trained with all of this data. But you can actually reduce all of this cognitive thing to a very specific domain if you want, and train your models on only very specific area of data. Now, That is now there are two parts to it, right? One is the embedding part, the other part is the inference part. Now, embedding, we already have RAGs. RAGs are essentially embeddings. So if I take my website data and then I feed it, I convert all of my website data into embeddings. Now I'm telling my large language model, don't think into this 40 terabytes of data that you have been trained on. Forget about all of those things. This is the only data set that I want you to look at. I don't want you to look anywhere beyond it. So from an inference part, it essentially embedding, I have generated the embedding for my website. I have stored it into a ChromaDB or a Fast Index on my system or wherever it is. And then I'm asking my LLM, now infer only from it. Don't look at anything else. So this is what we are today talking about as private LLMs or small LLMs, as the custom LLMs as they call it, which are getting built for specific areas, specific domains, etc. What they allow you to do is essentially to run LLMs at very small devices. You don't need a massive 3264 GB memory or 1000 NVIDIA GPU processors. In fact, I'm running this on a Mac Mini. I have my own LLM models which run on my own Mac Mini, and then I'm able to generate inferences from it. So short answer is yes. I don't know how many of you are interested. I can show you how I run LLMs locally. Very simple answer. Go to Olama. Olama is a tool system that allows you to download and run models locally. Okay, you can actually download most of the large language models that are available in the internet, and also some specialized models, and you can run them just on your desktop. If it has it has to have a decent amount of memory. If it's a fairly decent laptop or a desktop, it might be slow, but you don't need to buy GPTs, OpenAI subscription or any of the subscription. You can run them locally on yours, which is what I do for all the
What
test.
are some models you're running locally?
Let's see. Let me see if I can share my desktop and show you guys. Let's see. Content only, background. Okay, share. You guys can see my entire screen.
No, we can. Yeah.
Let's see. You're able to see my terminal?
Yes.
Yeah.
So I'm running DeepSeek R1. I'm running Gemma 3. Like these are embedding models. So when I write a RAG model, I have to take my own personal data and then I have to convert it into an embedding. Embeddings are beautiful. There's a very nice about an hour YouTube video. If you guys are interested, I'll share it with you on that beautifully explains what embeddings actually do. Think of embeddings like answering machines. So I said my name is Lakshmi Narasimhan. Embeddings essentially ask a number of questions to every single word. For example, the first word is my. It'll ask, are you a dog? The answer is 0. Are you a cat? The answer is 0. Are you referring to a person? The answer is 1. So similarly, they can ask a lot of questions. So the more the question you are able to ask for every single word, the more accurate you are able to describe it. So when you look at embedding models, they will say it has 1024 embedding, it has 2048 embeddings, blah, blah, blah. This essentially roughly means that for every single word, it can ask 1024 questions and find the answers for it. So I have two embedding models running locally, Nomad and Gwen 3. I have two inference models that I have with me, which is DeepSeek and Gemma 3. I can pull anything like one. For example, I can say Olama pull Nama 3.2. It's a huge model. So it is a 2 GB model. So this model now will be downloaded and available for me to use. So when I'm running an LLM or when I'm running my inference model locally, I can actually change my code to say call Llama 3 and then do it. Okay, when this guy finishes, I'll show you something nice. So for example, if I say Olama run DeepSeek R1. Now this is actually running the model on my system. My system is a very old Mac Mini, so its GPU power sucks. But this is just to show you that you can actually run. So for example, it's asking me a question. Let's say, who is the Prime Minister of India? Now you can actually see how slow it is. But this is just to show you that you don't need expensive subscriptions. Subscriptions are great, by the way. I mean, they make your life much faster if you want to really do this. So, but you can see that how slow it is if I have to run the same question on my old Mac, and how fast it is if you run it on a cloud-hosted GPU provider. But this is what I do. I run most of my models locally, at least for embedding generation and inferences. When I have to put it into a public domain for other people to use, typically I use OpenAI subscription because I have one. So I put the AI, I put the OpenAPI key, and then I switch it there when I put it out on the public, so that it's a lot more faster at least. See, look at this. It's actually telling you, right? It's actually telling you how it's thinking through this, what all it's considering to come up with the answer, etc. So it's a good thing to learn. Okay. Did I answer your question?
Yeah.
Okay, so Olama, yes. All right. Any other questions?
So Lakshmi, this what you're running right now, there is no agentic, right? You're directly
This is the prompt. This is like a ChatGPT prompt.
yeah. So when I so ChatGPT prompt, when you're using ChatGPT client, there is a agent sitting behind. When I send a prompt, it gives me precise answer. Whereas if I do take the same prompt, send it to the GPT LLM through API, when I'm directly interacting with the LLM through API, there's no agentic AI comes in. So
Okay.
so if when you run it here in Olama, is it like sending the prompt?
Yeah. It is actually what it's doing is it's loading the DeepSeek model in memory.
Right.
All the 5 GB of the embeddings that it had and the inferences models that it has. It just loads this entire neural network into the memory, and then it's sending this question. So it's basically tokenizing my question: who is the Prime Minister of India? And then it tokenizes and then generates embedding for it. And then think of it like an infinite graph that it has. So then the who question will actually, in its neural net memory, it'll start walking on one direction. Is, then it'll take a different direction. It'll take another direction. Prime Minister, because who is the could mean anything, right? Who is the chief minister? Who is the first American to win, or who is the captain of the Indian cricket team? So you can see that these are all divergent paths. Embeddings allow you to store these divergent paths efficiently. So it essentially keeps walking through the map till it hopefully finds an answer that it has. Now, when you run it through ChatGPT directly, what it does is it basically has a first layer of inference. I might be wrong here. Now, it has to now ask itself this question in terms of, is this information requiring me to pull the most latest information? Remember that this model that I'm running locally has been pre-trained with the data that it had. Assume that if the Prime Minister of India changed yesterday, this model will not know because I'm not asking it to retrieve the latest one. Now that's where the first layer of inference or an agent in ChatGPT might intercept your question to say, does this information require me to pull some more current information from some other space, or do I have this information with me? So it might say, for example, in this case, it says blah, 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 blah. If something happened today and I ask that question, let's say, what was India's score in the second innings in the last test match between South Africa? It wouldn't know because this model was downloaded a few months ago. But it does not have the intelligence to know that, hey, for this information, I don't have it. I am going to actually go and call Cricinfo or some other public website to pull this information. So most of the questions that you ask to ChatGPT start off a chain. The first thing being the ability for it to know, is this information with me? If not, which data source can I go and pull this information? And that's how it's able to give you fairly decent and fresh answers. Okay, any other questions?
Any of the last questions that we have to Lakshmi?
There are some things on the chat. I'm just looking through this. Okay, it's Nanda, you're sharing it. Okay, all right, okay. So great. Okay.
So Lakshmi, that apart from this Olama, there is one more GUI based um, application where we can run the LLMs, but unfortunately I couldn't run on my laptop. So
Locally,
it's
is it?
yeah,
Yeah.
locally, or there's one more. Probably it was saying that I need M series. Mine is also Mac. It says M series
Okay.
chipset. Are you aware of
Okay.
any other?
So I mean, no. I know Olama has a GUI interface on top of it that somebody built. I'm just too lazy, man. For me,
Okay.
this does my job. I'm like, okay.
Mm.
Most of the times I write code to interact. So
Mm.
this prompt and all, I never do it because I know it's pathetically slow. It just is so irritating. So just leave it at that. If I find it, I'll ping you, Nanda.
Sure. Okay.
Lakshmi,
All
great.
right. Sorry,
Yeah,
go ahead.
great session. Thank you. Lots to think about. So I've only been in the processing mode. But when I logged in, I think I caught the snippet of what you and Nanda were talking about, how at least generative AI is being adopted by the masses more rapidly than, at an enterprise level. So just, I'm curious about that.
So sorry. So here's the thing, right? Like enterprise level adoption requires a different set of mindset. But by the way, when I said that, I did not. Enterprises are largely adopting the developers aspect of LLMs. Now, when we say LLMs mean many things. Your Visual Studio Copilot, your Windsurf, Claude, Cursor, these are also large language models. It's just that those models have been trained on code. So they are able to predict what is the next line of code that needs to come. Just the way ChatGPT predicts what should be the next sentence, what should be the next word. Coding agents predict what should be the next function, what should be the next syntax and stuff like that. So most of these companies are generally okay with putting in coding assistance for reason that it's a lot more simpler to guardrail it. So you don't necessarily leak out information from your code to public domain and stuff like that. However, enterprise adoption of LLMs as systems starts. Now, remember that LLMs are expensive. They are not for every use case that you want to use it for. Where LLMs really work well is when you have to work with unstructured data, which is typically natural language, or systems or tools which are difficult for humans to process at scale and derive information from it. Like this is a picture of a cat or a mouse sort of a thing. Humans can do it, but at scale, maybe models can do it in some cases. So a lot of companies are essentially trying out on customer support, which is automating CS calls, etc. Because that's where a lot of human to human interaction happens, which is why you would see even now that when you call HDFC Bank, a robot will answer, and then it runs on some sort of a primitive voice recognition system with some limited capabilities. It's still not yet the scale of true enterprise level large language models, which have the corpus of all the information. Because solutioning is also very nuanced. Um, how do we put guardrails to ensure that your voice assistant is not telling the wrong answer to a customer? The customer calls and says, hey, I want to close my bank account. It may be easier to record it. Say, I'm not happy with your customer support service. I want to close your bank account. Now, a human might have a guardrail to say, oh, somehow I have to retain this customer. Maybe I'll offer them an incentive to stay back. I'll waive off some of their charges, or I'll give them a free lifetime credit card so that they continue to be my customer. Now, an agent, or in this case, a large language model or an agentic system, has to be trained with some of these guardrails and some of these motivations for it to behave that way. We don't want it to just, we don't want just an automation that says, okay, thank you, yep, goodbye, I'll close your account now. So that's more nuanced, and companies are working on it. On the voice support, on some of the summarization systems, we are seeing adoption or early prototypes at large enterprises. But I'm yet to see a truly world-class agentic systems being rolled out at scale at large companies. They're trying it in small pockets and where there's value. Again, as I said, 95% of things that happen in enterprises are better done with traditional software because they are fast, they are cheap, they are deterministic in nature. Generative AI and large language systems are good for subjective interpretation and not suited for every use case that you can think
Got it. Uh, since the time I've gotten into this space and I've been thinking about it, my very first, question was around how do you test or how do you know for sure what comes as the output, right? So while an LLM might be fast to respond, a human intervention may be required to actually verify or go through all of that comes out. So I was wondering if there's a correlation with that thought and the enterprise level uh,
Very
execution.
true, right?
Yeah.
Yeah, you are very
Even
true.
I've been, yeah, even I've been I've been into testing at some point in my career. So uh, it- there is a way that a tester operates and a developer operates. But then when we leave it all to the LLMs and the agents, then I'm so finicky about it. Like, how do you know the output is good? How do you know the output works in every condition, in every situation? So do you wait for it to fail? Do you wait for it to become a news, and then you wake up, or is there something around that? But I think, Lakshmi, your last line, the very last line, sort of also helped me focus that it's a very new space, 18 months old, and so much more to come. And I guess there are a lot more minds around the world thinking about these, aspects and working towards it.
Yeah, I mean, that's true. But it's a hard problem. Everybody's asking the same questions that you're saying, right? So what these systems are trying to do is they're trying to build credibility by, in some cases, citing the sources, especially if you use systems like Perplexity. They actually tell you the source through which they got that information that they actually provided. So that's one way for them to essentially say that what I'm telling is based on this. I'm just an inference model, and they just looked at this information and I'm relaying it back to you in a way that's easy for you to understand. But yeah, that's why I said that the biggest challenge with generative AI is going to be around guardrailing. And I don't know how many of you know this information, but today we no longer have data to train these models.
Oh,
They have already been trained with all the available information on the public internet. And somewhere I read that
We hear that they are creating data to use
yeah,
as training
yeah,
data.
yeah, they generate synthetic data. So we no longer have text data. And I was told, I read somewhere that by next year or the year after that, we will be running out of images to train these models. So this leads to what in computer industries we call the poison pill, which means that if it's garbage and the information that the model generates to train itself is garbage, then the information that comes out will become garbage. So
garbage in, garbage out.
yeah, so there's this over a period of time, if that trend continues, then you'll end up seeing deteriorating results over a period of time because but the funny thing is, as humans, will we be able to differentiate that it's garbage or not? Because
Exactly. Yeah.
because the
So,
information that we see is also this garbage. So
yeah.
so yeah, it's a funny world. Cool, man. So thanks a lot, guys. This
Thanks.
was super interesting discussion. I love the conversations that happen after the presentation. So happy to chat up with you guys anytime you want. We can talk. All right.
Thanks,
So
Lakshmi,
find me on LinkedIn, message me. Hey, thanks, Nanda, for this time.
Yeah, and thanks for making come here and then talk about all the knowledge that you have sharing with us. Hopefully, we will create. I mean, of course, data are for LLMs. There's no more new data, but for us, there are a lot of things to learn. Yeah, we will continue to learn.
Nicely put, man.
Mm,
Thank you. Thanks a lot. Okay. You all
cool.
have a great weekend. Thank you, guys.
Thank
Bye-bye.
you.
Yeah.
Thanks,
Bye.
Thank
Lakshmi.
you.
Thanks, Nanda.
Bye-bye.
Bye.
Thank you. Bye.